always want the method first. What I like about these, number one, well, they're kind of freaking cool, but besides that, same steps are going to work every single time. So this is one of these equations. If you follow the steps, it's going to work. Step number one is move logs to one side. Numbers to the other. Move logs to one side, move anything without a log to the other. Number two, simplify using log laws. Simplify using log laws. Is your name Mitch? Could that be your middle name? Okay, that'd be great. Thank you. Change to exponential form. Change to exponential form. Number four, solve for x. And step five is going in red pen. Check for extraneous roots. Do you remember that term from last year? Extraneous roots. What's an extraneous root? Andrew.
Any negative number, because you can take the log of a negative number.
Or, a negative or?
Zero.
Zero. This is put in brackets. You cannot take the log of 0 or a negative. And I'll show you when we get down to the examples how we check for that. There's always a log equation on the exam. It always has an extraneous root because they want to make sure that you're doing that last step. So I can't see why there wouldn't be on your exam.
Will these exponentials that we convert them to always have common bases?
No.
We've only learned common bases.
Just make a note here, is these are non-calc questions. And the only reason I want to make that distinction is we're going to come down to the next section, which we'll do tomorrow, is these are calc questions. How do you recognize the difference? Well, a log equation has a log in it. Exponential equation has exponents. Exponentials are always calculator. Log equations are non-calc. So if it's got a log in it, it's going to be a non-calc question. So an exponential equation will always appear on the first part of the exam. These will typically appear on the second part of the exam. Okay, grab your paper. We'll start with the easy and work towards the hard ones. Step one, basically what you're doing is isolating logs. So we put anything with a log onto one side, anything without a log onto the other side. So take a look at this one. Are all the logs on one side? Are all the non-logs or the numbers on the other? Okay, so this one, step one, is done for you. Step number two, simplify using log laws. What that means is the side of the equation with your logs is you should be down to one log. So you've simplified it all down. You've taken the adding, making it multiplication, the subtraction, making division. You've moved those coefficients to exponents. Are we down to one log on one side? So step two is already done for you. So we're jumping in at step three. Step three is converting to exponential form. Who remembers how to convert to exponential form? Austin, walk me through it. And what happens to the log part? He disappears. What happens to the x? He just stays there. So we're going to have x equals 2 to the 3. Solve for x. What does 2 to the 3 equal? The last thing we do is we check. And how we check is we take whatever our x value was and we just put it back in our brains, not on paper, into where the x goes. And we just want to know, is this value negative? Did that x turn the value negative? No, because it's 8. So this is done. This is a straight up log question. That's the easiest they're going to get because steps 1 and 2 are done for you. Let's take a look at example number 2, and there's a whole bunch of stuff going on. So 5 equals log base 2x plus log base 2, 2x. Logs on one side, numbers on the other. So logs all together, non-logs on the other side. Done. Okay. Step number 2, convert or simplify the logs. So here I've got 2 logs. I need to smush those down into 1 log. So this one we're jumping in at step number 2. The 5 is going to stay as it is. How can I simplify the right-hand side?
Log base 2.
Log base 2. And if I'm adding, what do I end up doing with those 2 values? Multiplying. And I'm just going to do it step by step in this one. I'll actually multiply it through in the next question, or next step. So adding becomes multiplying. Now I'm going to simplify that up. So 5 equals log base 2. Well, what is x times 2x? 2x squared. Step number 3 is convert to exponential, and the reason we do that is that's the only way to get rid of a log in an equation. So you can't anti-log, you can't divide by log, you can't square a log. What's the opposite of a log? Exponential function, because they're inverses of each other. So the only way to make a log disappear is to convert to exponential. So the base is going to move over, bump the exponent up, log will disappear. So on the left I'm going to have 2 to the 5, and on the right I'm going to have 2x squared. The reason we need that step, it's the only way to get rid of a log in an equation. There's no other way. We can't divide by it. We can't multiply by it. That's the only way to make a log disappear. Okay, solve for x. What do you want to do? So when in doubt, always go back to BEDMAS. That's how we solve equations. What do we do first? Brackets, don't have any. Exponent, okay, what do you want to do with the exponent? Okay. Oh, I heard it. I'm going to grab the red pen, plus or minus. And I'm just going to write them out separately. So we have -4 and +4. But that's not the last step. What's the last step? Is we check. So in our head, we just come back up to the question. And it doesn't matter which one I put it into. We want to know is, does it make the value negative? So if I put -4 into here, is that possible? No, so that's called an extraneous root, and we just cross it out. If I put 4 in, are we okay? If I put 4 in this one and 2 times 4, are we okay? Good to go. This is called an extraneous root. Yes, if you were just to give me 4, I don't know, did you know there was -4 and you knew to cross it out? Or did you forget that when you take the square root, it's plus minus? How are we feeling so far? Okay, let's look at one. Now we got to jump in exam or step number 1 for the next one. So we kind of eased in with those 2. Here's a full-out log question. 2 times log x minus log x plus 2 equals log 2x minus 3. What your brain is going to want to do is you're going to want to multiply through those brackets. So you're going to want to take negative log times x, negative log times 2, and on the other side you're going to want to do log times 2x and log times -3. Can we do that? Why not? Yes, and we can't touch when the brackets are after the log. So if you were kind of like, I might do that, make yourself a note. You can't multiply through by log in this question. And again, it's what your brain's going to want to do because it's how we solve normal equations. But we cannot distribute the log through these binomials. So what do? Well, we go back to the steps. And I'm going to number the steps because we're going to have all 5 in this one. So step number 1 is we want all the logs to one side and we want anything without a log to the other. Do you want to move everything to the left or everything to the right? Completely up to you. It's not going to matter. Okay, so the 2 log x is going to stay. The minus log x plus 2 is going to stay. And all we're doing is moving this whole term over to the other side. So how do I get rid of a positive log 2x minus 3? So I subtract it. And what do I have left on the right-hand side?
0.
I have a 0. Step number 2 is I need to simplify using log laws. What happens first is coefficients become exponents. So this 2 is going to move up. So I get log x squared minus log x plus 2 minus log 2x minus 3 equals 0. The second step of simplifying, anything that's positive goes on the top, anything that's negative goes on the bottom. So I'm going to have 1 log. Where's my x squared going to go? On the top. Where is x plus 2 going to go? On the bottom. Where does the 2x minus 3 go? He joins them on the bottom. So that's why we practice the simplifying with log laws, was be able to do these equations. And I still have that 0 on the other side. So I'm just going to repeat. Coefficients became exponents. Adding became multiplying. Subtracting became division. So anything that was positive went to the top. Negative went to the bottom.
Is there a minus between the...
No, the minuses disappear when you simplify. So they're just multiplied by each other. Step number 3 is convert to exponential form. So the base moves over, bumps the exponent up, value stays where it is. What's the base for this one? 10. So I have that little imaginary 10 that's tucked in there. So he's going to come over to this side and bump that 0 up. So on the right, I'm going to have 10 to the 0, which I'll simplify in a second. What happens to the log? Disappears, and all that stuff is still left. So I've got an x squared, and a 2x, or x plus 2, and a 2x minus 3. Well, what do we know about 10 to the 0? So I'm just going to put the 1 on the right-hand side just to get rid of it. Step number 4 is solving for x. So the first thing I probably want to do is get rid of this denominator. What's the opposite of dividing by x plus 2 times 2x minus 3? So I want to take the whole bottom and I want to multiply him by the other side to get rid of him. So x squared is going to stay. And in theory, what I have is 1 times x plus 2 times 2x minus 3. Okay, so all I did was multiply by the denominator to get rid of the fraction. Okay, still have to solve for x. Well, what kind of equation has an x squared in it? It's quadratic. How many ways are there to solve a quadratic? What are the 5 ways to solve a quadratic? Quadratic formula. Calculator graphing. Completing the square. Factoring.
Common factor.
Difference of squares. Which method would you like to use? Okay, well, it doesn't matter which method. We got to figure out what's on this right-hand side. We got to simplify it out anyway. So let's FOIL this out. So I still have my x squared on the left. X times 2x, 2x squared. X times negative 3, 2 times 2x, and 2 times negative 3. Do you want to bring stuff to the left or stuff to the right?
Left.
Ooh, that was like 50-50.
Right.
How do I get this x squared over to the right? Okay, so 2x squared minus x squared. Let's combine the x's right away. So minus 3x plus 4x. And then I got a minus 6 sit in there. Factor, quad formula, complete the square. I'd go with factoring too. Poor Brazilians, like, I hate factoring. Ooh, that's what I heard. Agree? Okay, what do I do now that I factored? Split and solve. These are so easy now. Remember in grade 11 when you hated these? X equals? Okay, so how we check for extraneous roots is we put a -3 into all these places where there's x, and you just do this in your head. If any of them turn out to be negative, it's gone. What's going to happen here? It's negative, so he's automatically gone. Let's check 2. Again, if he's negative anywhere in here, he's gone. So 2 is okay. Here I'm going to have 2 plus 2, which is 4. That's okay. Here I'm going to have 2 times 2 minus 3, 1. He's okay. Final answer, x plus 2. You can't assume just because he's negative here that he's not going to work up here. You can't assume just because he's negative here, he's not going to work up here. Imagine I had x equal to -1. Don't write this down. And what I had up top was x plus 2. Well, when I put that -1 in here, what happens? It's positive, and that's okay. So don't assume just because it's negative here it's going to work. Likewise, don't assume because it's positive it's going to work. If I had x equals 2, and above I had x minus 4, what would happen when I put in 2?
Extraneous root.
So don't just assume from the values here. You do have to actually just check them up here, and we just do that in our head. Any one of them are negative, out he goes. Out he goes. Out he goes. So let's just back up and just talk about this one again, because it's our first one that had all 5 steps. Step number 1, we just put all the logs on one side. So it's just moving stuff from side to side. Step number 2 was simplifying. This is why we learned log laws and why we practice the simplifying. We get it down into one log. Step 3, we convert to exponential, so get rid of the log. Step 4, sometimes it'll be quadratic, sometimes it'll be linear. Wait till you have a cubic, because we did that in Unit 4. Whatever kind of equation in here, you solve it the way we always do it. And step 5 is just checking for extraneous roots. Again, the one on the exam has always had an extraneous root, so I'm just guessing by logic that yours probably will too.
Do you ever go from these equations to math?
No. No, they'd either say graph like yesterday or solve. I've never seen them combine. Could they? Absolutely. I've never seen it. How are we feeling so far? I know this is only the 3rd one you've seen. We're like, good. Let's do some more. That's as hard as they're going to get, by the way. That one's got all 5 steps. The beauty of the steps is they're going to work every single time.
Actually, they could get harder. There could be like a cubic or a point.
Oh, but we know how to do cubics. Cubics don't scare us.
Yes, but they are harder because of the guess and check portion.
Harder or more work?
More work.
If there was, you know, on the last one, there was like a rational. If we got a whole.
You're thinking graphing, you're not thinking solving.
Yeah, but even for solving.
Okay.
And then say x is not equal to like 3 or something. What is, that's irrelevant.
It's irrelevant to what we're doing here. Does that answer your question? Okay.
That's when you get like show that you knew that.
Step number 1.
Get all these ones.
All logs to one side, anything without a log to the other. Would you like to move everything to the left or everything to the right? Here's how I am lazy, so lazy people, watch here, is I just erase this and I make it a negative and then make that equal to 0. Is everyone okay what I did there? Okay, step number 2, simplify. So you have to get down to one log. You're making it smaller. So any coefficients become exponents. Anything positive goes on the top. Any negative goes on the bottom. Go ahead and simplify and then just wait for us. Do you hear like the sound of elephants? Okay, very good. Very good.
Some kind of card action.
Yes. Usually the photocopy paper card.
Seems like the Lion King. Yeah.
A stampede's coming, like from really far away. Where does the x plus 2 go? Where does the x minus 3 go? Where does the 4 go? And I'm going to tuck them in front just because it's where we're used to having coefficient. If you have them in the back, that's fine. And what do I have on the right-hand side? You'll notice fractions are really common here because we typically have some negative logs, so don't freak out if you're always getting fractions. Okay, step number 3. Yeah, get the log out of there, and what's the only way to make a log disappear? Exponential form, so go ahead and convert to exponential form. Just repeating, the only reason we do that is because it's the only way to get rid of a log. We can't divide by log, we can't anti-log, we can't magically make the log disappear. The only way to do that is convert to exponential. Now in your brain, if you can see it's 1, you can go right to 1. I'm going to just show the 4 to the 0, just so when you look back, you see what happened there. Does everyone understand why 4 to the 0 became 1? Okay, solve for x. Well, what did we do in the last example that looked really, really similar to this one? We took the bottom and multiplied it over to the other side, just to clear the fraction. So on the left, I have x plus 2. And on the right, let's multiply through the 4 right away to save ourselves a step. So 4 times x and 4 times negative 3. It's linear. That makes me happy too. Remember grade 9 when these were so hard? Now they're so easy. Do you want to take the x's to the left or x's to the right? Okay, so how do I get rid of this x? Okay, so 4x minus x. How do I get rid of minus 12? So 2 plus 12. X equals?
14/3.
And it's a fraction, and we're okay with that. No, we are. We're okay with that. If there were no fractions, we could never share pizza. Put it that way. Or pie. Or cake. Yeah. No, but then you'll get sick on pizza. You can't eat a whole pizza. No, you're teenage boys. You probably could. Yes. Are we done? No. So sometimes to check, it's easier if you put this into decimal, if your brain works that way. So what would this be in a decimal or a mixed fraction?
4.6.
So it's 4 2/3, right? So really we're dealing with 4 and a little bit. So again, I don't normally show this, but this is what you're doing in your head. If I put 4 point whatever into here, are we okay? 4 point something minus 3, A-okay. Final answer, 14/3. How are we feeling so far? Yep, sometimes there's only extraneous roots, so you just end up crossing them all out. Yep. Are you starting to see the similarity between the questions? Like I said, these are some of my favorite questions because there really aren't many exceptions. The steps are always going to work. And like, this is impressive math. Seriously, you show people this, they think you're smart. Step 1. How do we know? Because the logs are all together and anything without a log is already on the other side. Step 2. Simplify, smush it down into one log. Go ahead and do that. Turn and compare, a little high five if you have the same simplified log. Nice. A little painful there, but yes. One high five. Nice. 2 high fives. What do you want me to write on the left? Somebody high-five me? Somebody high-five me? I go. Step number 3. convert to exponential. Why do we do that? To get rid of the log. Go ahead and convert to exponential, get that log out of there. X plus 3 times x plus 4 equals 6. 6 to the 1 is 6. Okie doke, step 4.
Expand this factor.
Okay, expand this guy, because we gotta get the brackets out of there.
This may or may not be that question with only extraneous roots that Mohammed was asking about.
So they're both negative, so I cross them both out? No, we gotta check them. We gotta check them. So if I put a negative 6 here, fail. If I put a negative 1 here,
Pass.
that's okay. If I put a negative 1 here, that's okay. Don't assume just because they're negative that they fail. You've got to check them within the logs. This would be a 4-mark question on the exam. If you miss that extraneous root, it's 3 out of 4. So there's typically 1 mark if you get that extraneous root. Show me your thumb. Where are we? Good. Do you feel ready to try one with a friend? Or by yourself? Okay, I'll give you a couple minutes, then we'll talk. This is the least amount of work you're allowed to show. So you'll notice I've skipped some steps. If you've skipped more, put those back in. That's the least amount of work you can show for the 4 marks. That would be a half mark off once on the exam, because it's one of those 10 special things that we'll talk about.
I did on
Yep.
a few tests and
Who had it? Awesome. Questions? Do you see a similarity between the questions?
Yes.
Right? Same steps every time. 7, go to. There she be. Any questions? Anything you're not sure where it's coming from? Grab a pair of scissors and the sheet that's on that desk.